Jerry Hatfield is working at the Agricultural Research Service in USDA. So he has been involved in on-farm trial during the last 20 years, and he's working with producers, especially in the Midwest, to evaluate the effect of changing of management practices.
So I appreciate this opportunity and to talk to OFE and everything. I've been following all of this, and I think this is quite exciting in terms of looking at this. And I'm going to take you through a little story about how farmers are really viewing this, because since I retired, I've been working with producers directly, trying to get them and us to understand what really motivates them in terms of looking at innovation in terms of farming practices. This is a effort that I've done with Wayne Fredericks, which is who is a producer in northern Iowa. Just to put it in perspective, this is the map of Iowa. That red star is where Wayne's farm is located. So it's in the very northern part of Iowa. It's some could be considered to be cold and wet in all of this. Here's what he's done in terms of changes. He went to no-till soybeans in 1992 because weather prevented him from getting any tillage done. He'd been a conventional tillage farmer until that time. When it froze up and he couldn't get anything done, he just switched over to no-till beans, and that worked so well that he just never stopped from it. And then he switched over to no-till maize in 2002 based on the success of his no-till soybeans. Here's what his fields look like in standing corn stubble and the soybeans coming up in between the rows of that. Here's his strip till system that he uses for his maize production, and then that corn is planted directly into that strip. You can see where it's coming up in all of this. And then he introduced cover crops in 2012. The upper row is the cover crops in the soybean fields, and then the lower piece is the cover crops in the maize field. And he plants directly into those. I'll explain why this is all important, because the dynamics of all of this, and in working with Wayne, he has a rich data set that he provided to us. He has soil organic matter samples, as you see, going back to the 1980s. He gave us all of his yield monitor data across 10 fields that for 16 years we analyzed those. We have the weather data from the county, and we also have county level yield data that's available to us, because producers are always asking, where do they stack up relative to the county average in all of this? And so we've looked at many different things across his field: soil organic matter changes, field versus crop level, or field versus county level yields, the field uniformity yield, and weather resilience and all of this. Because when we see producers beginning to think about innovation, they're always asking the question is, how do my yields determine? What's changing within the fields? And how does this really impact my overall management decision? So we have a lot of innovation going on, but I'm finding that producers are asking different questions about what some of those responses are in terms of this process. Here's his soil organic matter data going back to 1984. This is just across 3 fields for simplicity. You see that kind of the green colored bar has started out at 2.3%, and then it's increased all the way to 4.3. You've got another field that's actually close to doubling. You can see this is the red bar is where we began to introduce those changes in management. The no-till strip till system. There's been about a 2.5% increase over the 25 years in all of this. And then we sampled the fence rows, the undisturbed part, to see what our potential was in terms of building organic matter, because producers are always asking this question. So I'm changing, where's my potential in terms of what I'm seeing in responses. And so you see all these different changes that are going on in terms of some of these dynamics that are going on. But what I've found is that producers are very, very interested in what their yield monitor data is telling them. And we haven't done a good job of being able to relate back to producers the changes that are within the field. So if you remember your basic statistics, you've got this mean, a median, a skewness, and kurtosis, and basically skewness and kurtosis we don't use very much, but here's a perfect example of it. If you're negatively skewed, you've got a lot of data at that low end. If you're normal distributed, and if you're positively skewed, you got a lot at the high end. And then the kurtosis is basically how tight you are around the mean. So what we did with his yield monitor data that has captured a lot of attention for producers across the United States that we've been working with is that we've begun to see, and this is just two different fields over time, 2004. These are loam soils and a silt loam soil. You can see in 2004, a lot of that yield distribution had a lot of yields that were in that low part of the yield distribution. What we did is we took the yield monitor data and we segregated it by soil type within the field and begun to look at how that soil was changing within the field relative to the management that was going on. You see, as we changed this, the skewness, we started taking those low yielding parts of the field out. That Franklin silt loam, we see the same thing. Across all the different soils that we've run across these 10 fields, we've seen the same thing going on, is that we're making our fields more uniform. And in making it more uniform, we're increasing profitability because now you're putting the inputs in. And so when we look at this shift from positive to negative to positive skewness and increasing kurtosis gives you a tightening distribution around the mean. Greater portion of that field becomes a profit center. I'm finding that this is what producers are really asking about relative to any change they're making is the so what factor. So what's it telling me within our field? And what we've seen is that the fields are becoming more uniform. We also see other changes going on that has become important to them. And it's really about how we're managing water. And if you think about just adding that residue cover, you saw in the early pictures, you see a lot of residue cover on that, is there are three things that we're beginning to see that's important. First is that that residue cover is protecting that soil against raindrop energy. So we get a lot of increased infiltration rates. We reduce the soil water evaporation. And then the third piece that we've discovered by measuring root distribution, a lot of those plant roots, both corn and soybeans, are near the surface so we can take advantage of small rainfall events. Conventional tillage, those roots are distributed very deep. In a lot of cases, our roots are within 5 to 10 centimeters of that surface, so they can take advantage of very small rainfall events. What that translates to is this, and when we looked at the county data, and we looked at county data across the Midwest, is that yields are negatively correlated with April and May rainfall. And we see this is because we delay planting, we have stress due to excess water. You see, and then yields are positively correlated with July and September rainfall. So we get water during critical stages with the highest water use. It alleviates that variation among years. Not only are producers interested in what they're getting, in terms of any one year, but what's their yield stability over time. And so we're seeing that there are different metrics that we need to be using for producers to help them understand. Here's his impacts. In 2004, his water use efficiency, how efficiently we're using water during that growing season. We increased from 8.6 kilograms per millimeter to 12.1. 41% increase. In other field, we had about a 50% increase. Soybeans were at a 26% increase because we've increased plant growth and we've increased the production per unit of water. And this is well above the technology trend that we see at the county level as well. Same time, we've seen an increase in nitrogen use efficiency because we've achieved all of this production without an increase in nitrogen inputs. So we've seen all these different impacts that are going on. So this on-farm analysis and how we're working with producers is that This change in uniformity is a combination of reduced tillage and cover crops, but it's really important to start thinking about our distribution of yields around the mean, the tighter distribution, the water dynamics and all of this. The cultural operations have become more timely. They are more efficient in use of their water, light, and nutrients and everything. And they're always dynamic management pieces. So if when working with producers, we have to understand that they're going to make tweaks all the time as well. So when we start thinking about innovation, I think we really need to be capturing the data that they have, not at the field scale, but there's a lot of use we can make out of their yield monitor data or insights into this. We can give new insights into producers on the impact that there's on profitability, yield resilience, climate resilience. So the partnerships with producers and innovation, when we bring these tools together, it gives them a value-added assessment that uses their available data, takes our expertise, and begins to work with that. So with that, I think I'm within my 12 minutes.